Welcome back, Deep Divers. Today we're diving into a question that one of our listeners sent in.
Oh,
They noticed something really interesting about a leaf, like just a regular leaf.
okay.
They were looking at the veins, you know how they kind of branch out?
Yeah.
And it made them think about, like, the way light spreads out, almost like rays.
Mm-hmm.
So they asked, could this pattern in the leaf, could it be connected to, like, the fundamental forces that, shape the entire universe?
Whoa, that's a deep thought for just looking at a leaf.
Right. It got me thinking, too, like, what if that leaf is holding some kind of secret code, like a hidden blueprint of, like, the universe's grand design?
That'd be wild.
So to figure this out, I thought we could, take a trip back in time, all the way back to the Big Bang.
Back to the beginning of everything.
Exactly. But we don't just want to go to the Big Bang itself. We got to go to those, like, crucial moments right after,
Yeah. Yeah, when those fundamental forces started to, separate and do their own thing, that's when things get really interesting.
Okay, so imagine we're rewinding the cosmic clock, right?
Yeah.
About 13.8 billion years.
Okay, I'm with you.
And the universe is just this, like, super hot, super dense soup of pure energy.
Yeah.
What happens next?
Well, in that first, fraction of a second, all the forces we know about today, gravity, electromagnetism, the strong and weak nuclear forces, all of them, they were all smashed together, unified, one big super force. But as the universe kept expanding and cooling down, really quickly, this super force, it starts to crack.
Okay.
And guess which force was the first one to break off? See ya.
Gravity.
Bingo. Gravity makes a break for it first, which kind of sets the stage for everything else.
Makes sense. Right. Gravity is like the ultimate architect. It shapes galaxies. It pulls matter together.
It's the force that brings all the cool stuff together.
Exactly. But how does that, relate back to our leaf?
Okay, so think of it this way. Gravity, right? It pulls things together, so it creates a kind of structure. It's like the scaffolding, the framework that everything else gets built on. And in a way, those veins in a leaf, they do the same thing on a smaller scale.
Right. They provide support. They channel, nutrients and water throughout the leaf.
Right. So it's like the leaf is echoing that same kind of structural organization that gravity sets up in the universe.
Okay, I see where you're going with this. So gravity's laying down the cosmic blueprint, and the leaf, it's following suit with its own little network.
Pretty cool.
What happens next in this, cosmic unmixing?
Well, after gravity pieces out, you've got the strong nuclear force. That's the next one to go its separate way.
Okay.
And this is a big deal because the strong force is all about sticking things together. It's like the super glue that holds the nuclei of atoms together.
Like the very heart of atoms.
Exactly. Without it, matter, as we know, it wouldn't even exist. No atoms, no stars, no planets, no leaves, nothing.
So basically, game over for the universe as we know it.
Yeah.
But hold on, how does that connect to what our listener noticed about the leaf? Like the veins in a leaf are made of cells, right?
Yeah. Right.
And those cells, they got to have atoms.
Exactly. And those atoms are only there holding their shape and doing their thing because of the strong force. It's the glue that's holding everything together, from atoms to leaves.
Whoa, that connection. I hadn't even thought of that. So we've got gravity shaping the big picture, the strong force holding atoms together. What about the other two? Electromagnetism and the weak force. Where do they fit in?
Well, they stuck together a little bit longer than the others, but eventually they split up too. And get this electromagnetism. That's the force behind light.
Okay, that's huge.
Mm-hmm.
So those veins, are they tiny fiber optic cables channeling light or something?
Not quite like that. It's not like the veins are literally channeling light, but they are a product of light because of photosynthesis.
Right. Photosynthesis.
Right.
Plants using light to make food.
Exactly. And remember, without light, plants couldn't make those intricate vein structures in the first place. They need light to grow and, do their thing.
So in a way, those veins are like a testament to the power of light, kind of like how galaxies and stars are shaped by light from the Big Bang.
Exactly. That connection that the listener made, seeing those veins and thinking about rays of light, that's not just a coincidence.
Yeah.
It's pointing to this deep connection between light and life itself, something that goes all the way back to the very beginning.
Man, I'm getting chills just thinking about it.
Mm-hmm.
All right, so we've got gravity, the strong force, and light. But what about the weak force?
Right.
And where does sound fit into all this? We haven't even touched on sound yet.
Okay, so the weak force, it plays a role in radioactive decay. which is a whole other story, not as directly related to Leaf, but super interesting.
Okay.
As for sound, this is where things get really mind-blowing, because even though we can't hear the universe, it's full of vibrations. Like, it's vibrating with energy all the time.
Hold on, are you saying like the universe is one giant symphony we just can't hear?
Kind of, yeah. And those vibrations, those resonances, they played a huge role in shaping the early universe, just like they do in shaping the patterns we see in nature all around us.
Whoa. It's like heavy.
Mhm.
So how does this cosmic symphony relate to our little leaf?
Well, look at how those veins branch out, how they create these like repeating patterns. Those patterns aren't just random, they're influenced by the way the leaf vibrates, the way it resonates with like everything around it.
Wait a minute, so you're saying the leaf is actually like responding to sound, like it's listening to the universe?
It's not listening in the way we do, but it is responding to vibrations. Things like the wind, the flow of sap inside the plant, even the subtle vibrations of the earth itself, all of that influences how the leaf grows and develops those intricate vein patterns.
That's wild. So the leaf is like a tiny receiver picking up on the universe's grand symphony and then translating it into its own structure.
Exactly. And you know what's even crazier? This same idea, this concept of resonance, it applies to the formation of the very first atoms way back in the beginning, specifically hydrogen.
Okay, bring on the hydrogen. I'm ready to dive deeper into that, but I have a feeling it's going to get even more mind-bending.
You have no idea. Just wait till you hear how this hydrogen atom, formed billions of years ago, is intimately connected to that leaf you're holding today.
Right, I am on the edge of my seat.
All right, so we've been talking about how those forces after the Big Bang really set the stage for like the whole universe as we know it.
Yeah, it's like they laid down the ground rules. Right?
Yeah.
But what about the building blocks themselves, the actual stuff that everything's made of?
Right, the very first atoms. And that's where hydrogen comes in. It's like the atom of all atoms, the OG element.
Okay, we left off on that kind of cliffhanger, the hydrogen connection. So lay it on me. How does this simple little atom tie back to our fancy leaf with its vein patterns?
Okay, so picture this a journey that spans billions of years, from the crazy chaos right after the Big Bang to a quiet forest with like leaves rustling in the wind. It all starts with a tiny hydrogen atom, one proton, one electron, that's it.
All right, take me back to that moment. The universe is cooling down, gravity's doing its thing, the strong force is in play. How does hydrogen actually, like, pop up?
So at that point, the universe is basically like this wild sea of particles, quarks, electrons all zipping around. But remember, the universe always wants to find balance to become more stable.
Right, like everything's kind of looking for its chill spot.
Exactly, and that's where electromagnetism comes in. Opposites attract, right?
Like magnets. Protons and electrons have opposite charges, so they're drawn to each other.
Exactly. But it's not just about attraction, it's about finding the lowest energy state. And for a proton and electron, that means becoming a hydrogen atom. That's the most stable configuration they can get to.
So it's like they're kind of clicking into place, finding that perfect fit. Not that they're thinking about it, but they're drawn to that balance.
Yeah.
I get it. But hold on. How does one tiny hydrogen atom, even billions of them, eventually lead to something as complex as a leaf?
Okay, think of it like this. How does a teeny tiny seed grow into a giant tree?
Okay.
It all starts with the basic building blocks, right? And hydrogen, that's the building block for pretty much everything. Now zoom out from that single atom, way out. We're talking about massive clouds of hydrogen gas floating around in space.
Oh, right. The star nurseries. I've seen pictures of those. They're amazing.
Yeah, they're huge. And gravity starts pulling all that hydrogen gas together. And eventually those clouds get so dense, so hot, they collapse and boom.
A star is born, and then what happens inside those stars?
A fusion.
You got it.
Yeah.
Fusion. And that's where things get really wild. Fusion is where hydrogen atoms get squeezed together. I'm talking immense pressure, crazy heat, and they fuse to form helium. And when that happens, a ton of energy gets released. That's the energy that makes stars shine. Whoa, so those tiny hydrogen atoms, they're like the fuel that powers stars. And to think, it all started with them finding balance, becoming stable. It's like they're these little powerhouses driving the whole universe.
They really are. But it doesn't end there. See, inside stars, fusion doesn't stop at helium. It keeps going, creating heavier and heavier elements. Carbon, oxygen, nitrogen, all the stuff we're made of.
Wait, so you're telling me the carbon in my body, the oxygen I'm breathing right now, it all came from hydrogen atoms fusing together in stars?
Yep. It's like cosmic alchemy. Stars are these giant element factories, taking those basic building blocks and transforming them into the ingredients for planets, for life itself.
Okay, that is officially mind-blowing. But how do those elements get out of the stars? And how does any of this relate back to our leaf?
All right, patience, patience. Remember, we're talking billions of years here. So some stars, especially the really big ones, they get to a point where they can't keep fusing elements anymore. They become unstable. And then, boom, supernova.
Right, a massive explosion. I've heard those can outshine entire galaxies. So that's how those new elements get scattered throughout the universe.
Exactly. It's like the universe is planting seeds, spreading those elements far and wide. And eventually, some of that stardust ends up right here on Earth, where it becomes part of, you guessed it, water.
Whoa, hold on. So the hydrogen that formed right after the Big Bang, it goes on this crazy journey, becomes other elements, gets blasted across space, and ends up in the water that nourishes our leaf.
That's the story. So those veins in the leaf, those rays of light our listener noticed, they're not just a pretty pattern. They're a direct link to billions of years of cosmic evolution.
I'm speechless. But hold up, we were talking about sound and vibrations before. You said that played a role in the formation of hydrogen. I don't quite get that part.
Ah, good point. So remember how we said light is electromagnetic radiation?
Oh, yeah.
Well, light interacts with matter in very specific ways. And hydrogen atoms, they absorb and emit light at particular wavelengths, like a fingerprint.
Right. Each element has its own unique light signature.
Exactly. And that interaction between light and matter, that resonance, it shapes the universe at all scales. It influences how stars form, how galaxies change over time, and even how a tiny leaf captures sunlight to make food.
Whoa, so that resonance our listeners saw in the leaf, it's like an echo of something that's been happening since the very beginning.
Precisely. It's all connected. From the first hydrogen atoms to the intricate patterns in a leaf, it's all part of the same grand cosmic story.
Yeah, I'm getting chills again.
Yeah.
Okay, but we're not quite done yet, right? We talked about hydrogen and stars and how those elements end up on Earth, but I'm still missing the water connection. How does that fit into all of this?
That's where we bring it all home. See, water is crucial for life, especially for plants. And you know what? Those hydrogen atoms, they don't just sit around in water, they actually give water its unique properties, the properties that make life possible.
All right, hit me with it. What's so special about hydrogen and water? Okay, so we've traveled from the Big Bang to the birth of stars, and now we're bringing it all back down to Earth, back to our leaf with those awesome vein patterns. And the key to this last part of our deep dive is water.
Exactly. Water, right. It's like the ultimate life giver, the molecule that keeps our leaf, all living things going. That those tiny hydrogen atoms we've been talking about, they're not just hanging out in the water molecule. They're what give water its superpower properties.
Okay, I'm ready for my chemistry refresher course.
Oh.
What's so special about hydrogen in water?
All right, so picture a water molecule, right? Two little hydrogen atoms bonded to one big oxygen atom. But the way they're bonded, it creates this imbalance of electrical charge.
Okay.
One side of the molecule ends up slightly positive, the other side slightly negative. We call that polarity.
Oh, right, tiny little magnets.
Exactly. And those weak magnetic attractions between water molecules, we call them hydrogen bonds. They're like the secret sauce that gives water all its crazy cool properties.
Okay, I'm with you so far.
Yeah.
But how does that translate to, life support? How does that help things actually live?
Think about it. Those hydrogen bonds make water super sticky. The molecules like to cling together. We call that cohesion. And it's what gives water that high surface tension. You know how those little bugs can walk on water?
Yeah.
That's cohesion in action. And it's also what lets water move up through those tiny tubes in plants against gravity, delivering nutrients all the way from the roots to the leaves.
Ah, so those veins we've been admiring, they're relying on hydrogen bonds to keep the water flowing.
You got it. And that's just one thing. Those hydrogen bonds also give water its high heat capacity, so it takes a lot of energy to change water's temperature. That's why oceans help keep our planet's climate stable and why our bodies can stay at a pretty constant temperature.
Right, so thanks to hydrogen bonds, we're not boiling or freezing all the time.
Yeah.
That's definitely important for life.
Totally. And don't forget water's superpower. It can dissolve tons of stuff. It's like the ultimate solvent. It's how plants absorb nutrients from the soil, how our blood carries oxygen, how so many things happen in our bodies.
So hydrogen is not just a building block. It's like a key ingredient in the chemistry of life. It all goes back to those first moments after the Big Bang.
That's right. It's like this epic cosmic dance. Hydrogen forms because the universe needs balance. Then it goes on to fuel stars, create other elements, becomes part of water, and ultimately makes life possible. And we can see that whole journey reflected in the pattern of a simple leaf.
All right, my mind is officially blown.
Mhm.
But there's one last piece I'm trying to fit in. We talked about how light interacts with hydrogen and stars, but how does that play out in our leaf, down here on Earth?
Ah, you're talking about photosynthesis, that amazing process where plants use light energy to make their own food.
Right? Sunlight, chlorophyll,
Yeah.
all that good stuff. But I don't quite see the hydrogen connection.
Well, think about what plants need for photosynthesis: water and carbon dioxide. Where do you think the hydrogen in those glucose molecules comes from?
Hold on. The hydrogen comes from splitting water molecules, the same water that's traveling up those veins thanks to hydrogen bonds.
Bingo. So those leaf veins aren't just transporting water, they're carrying the very source of hydrogen that'll be used to build the plant structure to help it grow. And the energy for that whole process, the splitting of water molecules, that comes from sunlight.
Whoa, so the light that our listener noticed, that light reflecting in the vein patterns, that same light is actually being used to unlock the hydrogen that powers the whole plant.
It's all connected, and it all goes back to that basic interaction between light and hydrogen, something that's been going on since the universe began. It's happening in stars, and it's happening right here in the leaves of plants.
I am seriously amazed. We started with this simple observation about a leaf, and we ended up on this incredible journey, connecting the formation of the universe to the chemistry of life itself. That's mind-blowing.
It is pretty awesome, isn't it? The universe is full of these incredible connections, just waiting for us to find them. And sometimes all it takes is a simple question, a curious observation, even just a leaf, to unlock some pretty profound truths.
So, to all our deep divers out there, keep your eyes open, keep those questions coming, and never underestimate the power of just looking around and noticing things. You never know what kind of amazing discoveries are waiting for you.
And remember, we're all part of this incredible story, connected by the same cosmic threads. From the tiniest atom to the largest galaxy, it's all connected. Pretty wild, huh?